Okay, so this is Query Analyzer. This tool I built it myself to help you find an N+1 query problem in your code base. And not only does that, it also helps you how to solve the issue. I know some of you might not be familiar with N+1 problem or any tool that it's helped you to solve the same issue, but let's take a look about what is N+1 exactly. But before we get into details, let's see how we can use Query Analyzer in the code base. Uh, there is no complicated configuration. You can just copy this dependency in the POM file, or you can use Maven or Gradle, both works, and it will does the job. This is what I did here. Of course, you can change some other configuration, but it's optional. I'm not going to get into details in that video. But you can read the documentation and do whatever you want. And yeah, enough talking. Let's talk about the N+1 problem. And this is a generic Spring Boot application. You have the order entity and the user entity. Now let's say that we want to get the orders for each user, and I'll do that in a JUnit testing class because I wanted to introduce you to a new annotation that it's provided by Query Analyzer. It's no N+1 problem. This one is used for regression testing. It tells you whether this block of code has N+1 problem or not. So if you've never heard about the N+1 problem, this block of code might be normal. You're just fetching all of the user inside a list, and for each user you're getting the orders for that user. So yeah, this looks normal, but the ORM is tricking you into thinking that you're executing one query, but you're actually doing N+1. This is the first query here, and this is inquiry, and this is the thing that you don't know about it. And let's try to run this block of code here and see what we're getting. Well, that was expected. You got here, there is a 10 repeated queries in the orders, and the location, it's in the line 26, and this is the example of the how the SQL will look like. And it tells you this suggestion. It tells you that there is a N+1 query pattern detected, and it tells you how to fix it. You can use the join fetch trick, or adjust the patch size, or use the entity graph. And this is what I did. I did use the join fetch trick here in the code. I'm simply telling the ORM to get the order for each user at the same time. So you don't have to hit the database a lot of times to get the orders with the users. If I change this block of code here to find all with orders, it should run fine without any problem. Let's see. Okay, perfect. That was it. Let's take a look at another example that we have here. Let's say that this is our Spring Boot application. Let's run the application. And those are the examples that we have. This is a bad example that we have here. We're doing actually the same thing that we did in the JUnit testing class, getting all of the users, and for each user we're getting some other stuff like ID, email, whatever, blah blah blah, and then we're returning a entity response. So if we try to hit this endpoint here, it will give us a report about what's going on. So curl host 8080, and let's copy this one. Oh, I'm sorry. Okay, let's see what we're getting down there. Okay, so you can see here the orchestrator told you that it analyzed 11 queries. It's a N+1 pattern here. we're using H2DB, it's in-memory DB, and this is the report, which is the most important thing. It told you that there is a N+1 query detected, and this is the location, and also it's in line 48, and it tells you that there is a confidence score. I will talk about this later, not right now, and it tells you the same thing here. You can use join fetch or batch size or wherever, and this is the fix for the N+1. You can try it. You can try those on your local machine. I'm not going to cover all of the examples here. And I noticed here that it told you that it took 0 milliseconds to execute, and this is because we're using in-memory DB. We're not using Postgres here. If you wanted to use Postgres, there is another example for Postgres. You can try it out. It will take time to execute. So yeah, that was the idea of query analyzer. Let's look about the architecture that we have. Some of you might be scared of the architecture, but it's pretty simple. We're not doing much work here. But I'm not actually a fan of slide reading, so let's get our hands dirty and see what's going on exactly. Let's go to Excel Draw, and let's start from scratch. Let's say that you have your Spring Boot application here. So this is the controller, this is the service, and this is the repo. So that's the controller, and this is the service, and this is the repository. Okay, and let's say that this is the client. You're trying to execute any query, for example, getting all of the users, like what we did before. So it will go to this service layer. First thing, it will, of course it will have the controller, but the logic is done with in the service layer. And regardless the ORM that you're using, whether you were using a Hibernate, let's see here, this is, or my bat is, for example, or joke, or whatever the ORM that you're using. So they all has to get into one door, which is the JDBC door here, because we're not actually dealing with a specific ORM, we're dealing with the JDBC level. So this is the JDBC. So whenever you're doing any JDBC call, our query analyzer will execute. So the first thing that it see here, this is query analyzer, and we have actually three main proxies. The first one is the it should be the data source proxy. This is the this is actually a connection pool. It hands out the connection, so we wrap those connections, so everything that it gives is already ours. And from the data source, it will go to the connection proxy, and this one, it's a one live session to the database. It creates the statements. We wrap every statement, so it's ours too. So from the data source to the connection, and from the connection it will go to the most important part, which is the statement. So this statement where the query is actually execute, when you run this execute function for any query, it's done here, and it also tells you how long the query took to execute. So this is pretty important here. And it also hands out the SQL queries to another thing that we will explain here. We're not doing actually any changes on the database call, so this is the database. We're currently supporting Postgres and H2DB, and also there is MySQL. Okay. Okay, not much work to be done here. And from this statement, it will go to another block down there, which is the this is the query tracker. Well, you can consider this as a cleaner. It cleans the capture queries and normalizes the SQL, and it also trims the stack to your code and stamps the timing. It does a lot of things actually. So from this statement, it will go here. So the query tracker, and actually for everything that we're doing, we're saving it in a private per request notebook. You can consider it as that. It's a local thread store. Local thread store. So as I told you, this is a private per request notebook, so each request get its own user will not mix, and you don't have to care about the locks, like you don't have to make any lock, and it will go from here to here. Okay, I think we're good in that. And those are considered to be the main parts of query analyzer. So after any server let request finish, it will go to another thing down there. This is query. Okay. So as I told you, whenever a server let request finish or any DB call, it will go to the last part, which is the first thing here is the grouping. Well, what I mean by grouping, we're piling the queries with the same shape. So if there is, for example, if there is a 10 identical queries, we're pile those queries into one single query. You can see here, you can see here when you use the query analyzer, you're not getting repeated queries. We're just getting one single query instead of 10, for example. And from the grouping, it will go to suppress. What I mean here, we're actually dropping the innocent repetition, because some of you might think that every repeated query in the code base, oh, this is a N+1 problem, and this is not the case actually. For example, if you have a pagination or pooling or patched inquiries, those are considered as a innocent queries, so you don't have to report those in the reporter. And this is the job of the suppress. And the last thing, which is the confidence. And remember this one I told you, it gave us here in the report, there is a, I think it was 100% confidence. Yeah, that was it. This is the well, The confidence depends on a formula that I made, and I will tell you why I choose those numbers. Those are not actually magic numbers. Okay, what I'm doing. So here's the scoring system. Score is equal to the 0.5 times the frame work plus 3 times the location, 0.2 times the timing. And this is how we're getting the score confidence. And you might see there's a different weights. I choose to take the half of the weight to the framework because this is the strongest evidence. Seeing Hibernate lazy loading the classes and the stack always mean that it's a genuine lazy loading N+1, so it's really hard to fake. This is the strongest evidence. And I gave the location 0.3 because same call site means a loop hitting one line repeatedly. So, you know, it's a good signal, but it's legitimate code. Those might be like repeated line. It's not a big of a deal. And I gave the timing 0.2 because you know, it's spread out. It's equal to pooling, so it's useful. It's useful, but it's a bit noisy. So we're not depend on timing because the query might be executed on different machine. It will take, you know, different time from a machine to a machine. So I choose to give it 0.2, and that was for the scoring system. So that was it. And the last thing that we get here is the this is the reporter. So yeah, that was it. The reporter, it's just like, you know, printing what we got here in the code. Of course, the implementation, it's not that easy, but this is the full picture. This is the architecture. I hope you understand it. And yeah, I think I'm done with that. If you have any question, you can just ask in the comments. I'll be helping you. You can also email me. I'll be helping you too. Thank you for watching, and that was it.